Hi there, my name is Chenuka. I'm an MSc Computer Science student at UCL, and this is my final video demonstrating my project for my end-of-year dissertation. MotionInput version 2 for 3D model navigation with specific application to the HoloRepository Portable 2021 and touch-enabled 3D model viewers. This is a UCL Industry Exchange Network project with industry partners Microsoft and
Great Ormond Street Hospital for Children's Drive Centre.
So, what is this project? It's centered around touchless computing, and to explain what that is, the picture on the left is a very good demonstration of that. It's essentially controlling your device with no physical contact with that device whatsoever. So you're not touching a touchscreen, you don't have another peripheral device in your hand or on your person anywhere. You don't have any wearables like an armband or a headset, and you certainly don't have anything installed in your brain either. And to describe what the project actually is, it's developing a suite of touchless gestures for 3D model navigation. So those will be things like rotation, panning, and zooming in and out. And specifically, the suite is designed for clinical use. And the 3D model viewer of choice is the HoloRepository Portable Viewer 2021. More on that later. And as an extension to the project as well, it will also be designed for touch-enabled 3D model viewers. And all of this work will be incorporated into the MotionInput version 2.0 framework. So, how does this project deliver value? Well, you can see on the left-hand side, there's a storyboard, which is going to be a good demonstration for that. You can pause the video to read it if you would like. But I guess the most important thing is it will eliminate the risk of pathogen transfer from device to clinician to patient. It'll save clinicians time from having to sterilize their hands or equipment. On top of that, it's convenient as well, so you can control your device remotely away from your workstation, and you don't need to have any other peripherals on your person. It'll be open source and readily available, and on top of that, you don't need any specialized expensive hardware, unlike with Azure Connect, Leap Motion, MyoArmband, or Neuralink, or any other competing products. All you really need is a webcam. Well, as mentioned earlier, the work in this project will be incorporated into the MotionInput version 2.0 framework. What is that framework? MotionInput is an off-the-shelf touchless computing solution which allows the user to interact with their computer using simple camera input. And that's where the open source nature of this project comes from, as well as the fact that all you need to use is a webcam. And there are multiple students working on this framework, each of them contributing their own projects to it. Here is the system architecture diagram for MotionInput version 2. It's made by Ashil Kumin. So note how the framework has different modules. We have different modules for eye tracking, head movement, hand movement, and exercises as well. And my project in particular is contributing to the hand module. So if you look overall, we have two applications in general. We have a front-end application and a back-end application. The front-end application is a C#/WPF application, and essentially what that is just a front-end GUI where users can select the module they want to run, as well as the use case, and change some settings before starting that backend application. The backend application itself is where all the heavy lifting is done. So it's written in Python. It takes a webcam input and it feeds in the frames of that via OpenCV into various different machine learning models for landmark recognition. And the models we use differ depending on the module you're using. For example, in the hands module, we are using Google's MediaPipe. So then there'll be some processing within that model, and then we take the outputs from that, and via MotionInput, we transform them into events that we feed into the Windows event queue. So, onto the actual project work. We are going to start off with the gesture suite for the HoloRepository Portable Viewer 2021. And let me explain what that is. It's a portable Windows-based 3D medical model viewer application built in Unity. It's created by UCL students Bryn Lewin Jones, Shuai Yuan, and Daniel Rempel. And the aim of the project was to kind of get all functionality within this working touchlessly. So examples of that would be to be able to navigate the UI, select and navigate the models, create cross-sectional views of those models, and each of those models would have different segments, so being able to change the segment opacity and color as well as creating annotations within them. So the first feature is rotation. It's simply a pinch between your index finger and your thumb. This click and drag functionality was actually made by Ali Hassan on the MotionInput team, since it's quite common across the use cases. And you can actually use this to click and select some of the UI elements as well. So some of the bullet points in the previous slide get fulfilled by this functionality as well. Zooming is performed by engaging the rabbit pose on each hand and changing the distance between your hands, and this is inspired by how you zoom on mobile devices.
Panning is performed by engaging the rabbit pose on your non-dominant hand to bring up an on-screen joystick. You get 360 degrees of motion with it, and you could potentially find other applications for this, like in video games. For the panning joystick, I've created another mode, which I call toggle mode. You do a gesture to activate it, you move your hand as you need, and your palm is open so you can do other gestures and other activities if you'd like, and then finally to deactivate it, you use another gesture. Lastly, the HoloRepository Viewer also allows for the creation of annotations, and for this I needed a way to get text on screen without touch, so I opted for speech to text with this option. And all you need to do is engage the double barrel gun pose.
There is a tumor in the frontal lobe.
And there you go, you can see it working there. So currently this is using Google Speech to Text API, but hopefully in the future this can be expanded to include offline solutions as well. All of this work culminated at a testing day at Gosh, where clinicians could actually try out the system. Got some really useful feedback and some useful discoveries. Something interesting I found was that lighting conditions affect the system quite a lot. Hand flexibility as well was a little bit of a barrier, and there was a little bit of a learning curve to the gestures in addition to that. Another area of improvement that I've thought about is improving the panning sensitivity.
So next, we're moving on to the gesture suite for touch input, specifically touch-enabled 3D model viewers. So where does this idea come from? It comes from the fact that I noticed that many touch-enabled 3D model viewers use the same gestures, so single finger to rotate, two fingers to zoom in and out, two fingers equidistant to pan. It's very easy to use, and the correct term, I believe, is natural user interface. You can use this on multiple different apps. That was the Windows 3D Viewer app. You just saw the Marmoset Viewer now, and there are many other 3D model viewers online which you can use. Idle state is a creation of Ashel Kumin, and I am using it here to make cursor movement a little bit more like a mouse. The user can deactivate cursor motion by entering idle state, like lifting your mouse off its surface. Then reposition your hand to somewhere a little bit more comfortable. Then reactivate the cursor motion again by exiting idle state. The cursor moves relative to its last position before being disabled, unlike before where it would just jump to a new position. The advantages of this are being able to use multiple screens regardless of the layout, and also being able to click elements nearer to the screen corners whilst your hand is still in an optimal position right in front of your camera. The addition of a contact radius as well, being added to touches, also makes pressing small UI elements a little bit more forgiving. In the video, you could also see me use the Windows Touch API in the browser, which is quite easy because it makes it a little bit easier to scroll and zoom in and out. Touch rotation is basically identical to how it was in the HoloRepository, except this time round we're using touch events instead of mouse events. Touch zoom is quite similar to how it was in the HoloRepository, except this time we're using an index pinch on each hand, and to show how precise this is, I'm attempting to zoom into this bee's eye, and this is just emulating that double finger contact that you saw in an earlier demonstration and moving those fingers together and apart. There are two options for touch panning. The first one is to index pinch on both hands and move both around while keeping your hands equidistant from each other. This is the better option if you want to pan and zoom at the same time. The second option is a dedicated panning pose, which is the double barrel gun pose that you can see. And you'll see me use that in a bit. And yeah, this option is just better for pure panning.
And for the last bit of the feature set, I'd like to talk a little bit about the GUI and other contributions I've made in this project. So this is the GUI. This is that front-end application I talked about a little bit in the system architecture slide earlier in this presentation. I need to point out that the GUI was primarily designed by Ashil Kumen, with each MotionInput team member designing their own settings pages. And on the left, you can see a sort of user flow for how you would go through to select my use case and start using the features that I've incorporated into the framework with my project. So basically, all you need to do is begin by clicking the motion input icon, and then you choose the hand module next. Then you go back to the home screen where you click the configure button, and that's where you can select the different use cases within the hand module. And what you really want to select is the touch points recognition and 3D image navigation use case. Once you select that, click next, and then you just get to the settings page, and you can change the settings as you wish. So for example, in there you can see you can choose whether you're left-handed or you're right-handed. You can select touch radius for how big you want the touch contacts to be. There's a cursor sensitivity in there as well, which is quite important. If you feel like your cursor is moving a little bit too slowly and you have to reset your hand too much, that can be quite helpful as well. There are key mappings for the joysticks and whether or not you want to enable that toggle mode for the joystick as well. That's in there as well. So once you do that, you press save, you go back to the home screen, and you press start to start the backend application. Lastly, I would also like to mention some other contributions I've made to the framework, which I've listed below in this slide, and I'm going to attempt to briefly go through them. I think the main thing was handling the user settings and passing them between the front-end application and the back-end application. Quite a lot of work went into that. Quite a lot of work also went into compiling the framework and building the releases and demos that got sent out into the world. I will also have a compilation guide included in my report with all the details necessary for future people working on this to compile the framework. I also did some preliminary work on being able to remap gestures to other actions. More details on that in my report, and I believe it'll be a useful feature in the future. I developed the folded gesture primitive, which is basically a Boolean value, which is calculated for each finger. It's true if a finger is folded over, and false if a finger is not folded over. And the reason it's a primitive is because you can use it to build other gestures as well. I also changed the landmark draw function a little bit so that it's clearer when it's in idle state and not in idle state. Also, the ability to toggle it on and off via the GUI is something that I worked on as well. I made some front-end GUI changes, which I've just listed there below. And also, the final bullet point was that I also served as a team lead alongside Ash.
So I just wanted a slide to summarize all the achievements in this project. Of course, from the previous slide, there were the other contributions to the GUI and the MotionInput Framework itself. But more generally speaking, two separate touchless gesture suites were developed, one for the HoloRepository and one for touch-enabled 3D model viewers. And both of those suites were centered around 3D model navigation, which includes rotation, panning, and zooming. Within the HoloRepository, other features include general touchless UI navigation, touchless speech-to-text, and relative mouse motion for easy hand repositioning. And within the touch-enabled 3D model viewers, there was the alterable contact radius for clicking small areas of the screen. So just to conclude, I'd like to highlight some key achievements by the MotionInput team and things that I'm personally quite proud about. We've got an academic paper pending review, and we've got a Microsoft article publication as well. The links to both of those are on this slide. We've also got future talks with the Microsoft Global Ambassadors Help Program planned, as well as with the British Computing Society as well. I would like to also say that I've had an excellent time on this project. I've learned a lot, and I'm really excited to see what happens to the MotionInput framework in the future. On this final slide, many thanks are in order to a number of different people. Firstly, let me start off with my academic supervisors, Dr. Graham Roberts, Dr. Dean Mohamedally, and Sheena Visram. I would also like to thank the industry partners as well. So from Microsoft, Lee Stot,
and from Great Ormond Street Hospital Children's Drive Center,
Dr. Andrew Taylor, and many of the other clinicians at Gosh Drive, which have provided their insight. Last but not least, I'd like to thank the MotionInput MSc Computer Science team, including Ashil Kumen, Ali Hassan, Robert Shaw, Theodora Ganeva, Guanlin Li, Qianling Lu, and Yang Zhu.